we are going to cover surface area of circular solids. And what a circular solid is, it is the rounded out version of our prism, our pyramid, and then the last one is just a regular sphere. So we have a right cylinder, which think of that like a soup can or any sort of can that you know, or a tube of a paper towel roll, that sort of thing. A right cone, think about an ice cream cone, snow cone, all that good stuff. And then a sphere, think about a basketball or any sort of ball-shaped figure. So for these formulas, we're going to take the formulas that we have for the prisms and for the pyramids, and then we're going to round those out so that they incorporate the measurements that relate to our circles. So for the first thing here, for a right cylinder, the measurements that we are going to need is the radius of the base. So think of this where the top and the bottom of this cylinder, this can, is a circle. So it has a circle of radius r, and then the height of the cylinder, the distance between these two circular bases, we're going to call that h. So if you have ever taken the label off of a water bottle or the wrapper off of a can, hopefully you are aware that if you were to lay that out and think about what shape you form, you are going to form a big rectangle. So if I were to take off the lateral sides of this can and lay it flat, it would lay flat like a rectangle. I know that the height of this rectangle is the height of the can itself because it has to go from bottom to top. And then if I think about if I want to perfectly cover this can without any overlap, the sides to come perfectly flush with each other, seam to seam, the width of this box has to wrap around the edge of the circle. Well, what measurement goes with the edge of a circle? That's circumference. And so circumference has a formula in terms of the radius of 2 pi r. So when we think about the lateral area being the sides that are not the bases, then for this, it's just a rectangle. Base times height gives us the lateral area formula of 2 pi r times h. So 2 pi r h. That is our lateral area for a right cylinder. So then next up, we just need to add in the past to represent the area of the base because the shape could be different. We've been doing a plus b. But in this case, since it's a circle, we have one formula that we can use each time. I want you to stop and think, what is the formula for the area of a circle? And it is pi r squared. So then for adding in the base, it would be plus pi r squared. How many bases do we have? We have 2 of them. And so that makes our TA is the same as, it means total area, or it's the same as surface area. I go back and forth between those. Is going to be our lateral area, 2 pi r h, plus we have 2 circles, so 2 times pi r squared. So our total area of a right cylinder is 2 pi r h plus 2 pi r squared. Alrighty, so that's the cylinder. Let's go on to the cone. So again, sometimes it's helpful to think about what it looks like to open up a cone. If you have ever opened up a cone before, I'll do my best to sketch it. It usually looks like a portion of a circle with a chunk taken out of it like this, and then we can round it out and it comes together. So it usually looks something like this. But in terms of calculating this formula, we're going to do a little bit less analysis and go more straight just for this formula. So there's a couple of pieces that we need. We still need this base has a radius of r, so we still need to know what the radius of the circular base is. And then we are going to use, this cone does have a height straight from the vertex down to the middle of the circle, but we are going to be most concerned in terms of this cone with the slant height. So we care about the slant height. And so here is our formula. The lateral area, that paper part on the top, not the base, is going to be pi times the radius times the slant height, or pi r l. Pi r l is the formula for the lateral area of a right cone. All right, and then next up, once we have this, we need to add in our base. We want to think critically here, how many bases do we have? We have one of them, which has an area of pi r squared. So that would make this pi r l plus the area of the base, which is pi r squared, and this is our formula for the total surface area of a right cone. All right, awesome. Next up, we have a sphere. Quick note on a sphere is that a sphere is made of taking some central point and fixate and counting out a certain radius distance in every single solitary direction. So any direction that I were to draw, it will have a length of r. So I could draw to the top of this, I could draw to the front, and all of these pieces will have length r. So for this one, there's not great analyses. We just need our formula. The formula for the total surface area of a sphere, so all which is hard to cover in real life, but if we think about how much fabric would be used to cover a soccer ball, how much paint would be used to paint, a sphere, the formula is going to be 4 pi times the radius squared, 4 pi r squared. So here we have it. These are the formulas for today. Now, in this section, I don't know if I've said this yet, but I am not going to require you to do any memorization of these formulas. That actually even was the case when we were back in class and we weren't doing e-learning, because I would rather you show me that you know how to use them rather than get stuck on the specifics of the formulas. And so I allow you to use formulas. So rather than thinking, oh my goodness, how I'm going to memorize those, think about understanding them, starting to use them, and figure out where those pieces come from. So let's look at a couple of examples. All right, first one. We have a sphere, and it says if the radius of the sphere is 4, find the surface area. So for the surface area of a sphere with radius of 4, our formula is 4 pi r squared. So we just need to make a substitution. This is 4 pi times 4 squared. 4 squared is 16. That becomes 16 times 4. And so that makes this 64 pi units squared. So it would take 64 pi, which we could take the 64 multiplied by pi if we wanted to get the exact amount. It would take that much material to cover the surface of a sphere with radius 4. All right, let's go on to the next one. So for the next one, we have a right cylinder, and it says that the radius of my base is 3, and then the height is 11. Find the total area. So looking back up, it's the circumference times the height, so 2 pi r times h, plus 2 times the base, which is 2 pi r squared. So it's 2 pi rh plus 2 pi r squared. All right, we actually have all those measurements. We don't have to do any calculations. We don't have to do anything special. So that makes this 2 pi times the radius of 3 times the height of 11 plus 2 times, and now I'm just going to go ahead and calculate that area in our head. So radius of 3, that makes this a circle of area 9 pi. So 2 times 9 pi. That comes out to be, the first one comes out to be 66 pi plus 18 pi. Go ahead and add those together, and we get 80 pi square units. So what you'll find with circular solids, we're about to see one where we'll have to do a couple calculations, but for the most part, you will be given the measurements that you need and you won't have to do as many right triangle calculations to figure these out. All right, let's look at number 3. So number 3, we have a right cone. We have a cone, and it has a height of 12 and a radius of 5. For the cone, you can look back up, make sure you go back, you're referencing these formulas, but our total surface area is pi RL, so pi times r times the slant height, plus pi r squared. So pi RL plus pi r squared. So we want to ask ourselves, do we have everything that we need? And unfortunately, we don't have the slant height, so we need to figure this out. Remember that the height and the radii do form a right triangle, so then that makes that our slant height, this is a 5, 12, 13 triangle, and so we can calculate this to be 13. All right, so then now for our total surface area, This is going to be pi times the radius of 5 times the slant height of 13 plus pi times the radius of 5 squared. So 5 times 13 is 65, so that's 65 pi plus 25 pi, and those add together to make 90 square units. Alrighty, we're going to do one last thing, and then we are done with this section. So next up, we have I think this froze on me. Let me just restart this real quick. Okay, so next up, we are going to talk about what happens if I take a cone and I slice the top of the cone off. What happens? So we've given it a specific name, and it is called a frustum. So a frustum is the solid that remains when a cone has been sliced parallel to its base and the top part removed. So this is the upper part that is removed, and then the frustum is this guy right here. So we're going to look at piecing together, finding the surface area of that as we go. But first, we are going to find the total surface area of the full cone. So remember, for a cone, surface area is pi RL plus pi R squared. So for the full cone, the slant height, we are given the two pieces of it, but if we were to add those together, the full slant height is 12. And then remember, the diameter is 12 for this cone, but we need to cut that in half, giving us a radius of 6. So for our surface area, that makes this pi times 6 times 12 plus pi r squared, so plus 36 pi. That gives us 72 pi plus 36 pi. And that in total gives us a total surface area of 108 pi for the entire cone. All right, so it gives us a total surface area of 108. And so then next, our task is to find the total surface area of that frustum. So at this point, I'm going to break it down for us, but I also want you to pause it and figure out how could you do this, because I have not given you a formula for this, and actually I'm not going to give you a formula. Instead, we're going to solve it out and piece together what we know about cones and how these connect. All right, so let's look at what we have. So thinking about the pieces, it has one circle that will have the radius of the bottom cone. It has another circle that's radius will match the upper cone, the small cone. And then it's got the lateral area. It's kind of like wrapping around a trapezoid in a sense, making like a three-dimensional trapezoid prism figure. So yeah, making some sort of figure like that. And so then if we think about this, when I calculated the total surface area of the cone, the only parts I currently needed to remove is I need to remove the top part, and then I need to add in that circle, which I could easily add in the area of a circle. So I just need to figure out what the area of this upper cone is, and then I can subtract that off. So then that is going to be our next task. So let's just do, in this case, we just want the lateral area. We're going to leave out the base. So the lateral area is pi, I'll call this radius 1, R1, times L. Now here's the trick. We don't know what the radius of this cone is, and that provides an issue. I know the slant height is 4, but I don't know the radius. So let's think about what we have, though. I do know that the height of that little cone intersects the radius at a right angle. If I think about extending the triangle downwards, remember that we sliced parallel to the base, and so that makes this, we have parallel lines. We could do corresponding congruent angles. Those triangles are similar by angle-angle similarity, so we have similar triangles. So I could use a proportion to figure out the missing radius. So the radius of the first upper part over that radius of 6 would equal, well, let's see what other corresponding sides we have. We have the hypotenuse. So the upper one has a hypotenuse of 4. The entire triangle has a hypotenuse of 12. Let's go ahead and reduce this to make the mental math a little easier. 4/12 becomes 1/3. So it becomes 3 times radius 1 is equal to 6. So that means that radius 1 is 2. All right, so then that makes this pi times 2 times the slant height of 4. So it has a lateral area of 8 pi. So what that means is that I need to take so for my total surface area, let's switch to this color, for my total surface area of the frustum, it's going to be the surface area of the full cone that I found, subtract the upper cone lateral area, which is 8 pi, and then now, we did not ever include that circular base. It was on the inside, it was never included. But now that we've removed it, we do want to include it. And so this is a circle of radius 2. So it has an area of 4 pi. So then now we're going to add back in 4 pi. And then that gives us a total surface area of 104 pi. Alrighty, that is it for surface area. That is it for this section. Be on the lookout the next day that we meet, whether that be Wednesday for odd periods or Thursday for even periods, for a review activity that we are going to do to make sure that we're all set, all good on surface area before we move forward into doing volume. All right.